Shit. What's up, guys? Cody Miller here, back with another totally legitimate Halo speedrun. Okay, so I'm gonna make a lookup table in Java so I can check how my speedrun times have improved. As I'm gaming here right now at the GDQ Charity Speedrun Halo event, I hope that my speedrun times are faster than usual. I hope that they're not more than twice the time I intended, and I definitely hope I won't have to change the difficulty, as I can't play this game on normal mode cause I suck. Oh boy, let's look at the results of the lookup table.
Oh my god. Oh, hell no. It was a misinput. Calm down! You calm the
So, you need to store a bunch of elements, and you just want to directly get them all at one time, basically. What do you need to store it in? You need a lookup table ASAP. So let's talk about it. So you either implement a map or an array or even an array list. You just need to get the element like one time. So for a map, you would be using like the keys as the index, and for an array list, the equivalent to the keys would be the index, of course. So as an example, let's say you're given certain digit lengths as a bunch of code combinations, like a 5-digit zip code. Okay, what would be the total number of entries in that whole lookup table? It would be 100,000 entries, because we have to accommodate every single possible combination of the 5 digits. So it's going to be ridiculously large. And in reality, you're only using part of those entries if it's in the case of like a code combination like zip codes, since every zip code hasn't been like used yet. Hence, lookup tables can waste space, but they have fast lookup capabilities compared to other ways of storing these elements. Now let's look at another example. So you're given a program that implements a lookup table that can find full names of states from 2-letter postal abbreviations. How to find the index in that lookup table? Like, how do you get the index for that lookup table? Since there are 26 letters in the alphabet, for each of the letters, there's 2 of them, we need 676 entries, which we get by 26 times 26, because we need to accommodate for every single combination we can have with the 26 letters with the other 26 letters in the 2-letter abbreviation. So let's call the 2-letter abbreviation, the string that we get, abbreviation. To get the index for each character in the abbreviation, we could use, here's the code right here, int first letter equals abbreviation dot char at 0, int second letter equals abbreviation char at 1, int first letter equals character dot get numeric value, first letter minus character dot get numeric value, quotes a. It's basically the same thing for the second index. And I'm not going to go in depth on what it really means, just know it involves the ASCII table, so like, look up that stuff. Usually, you would think it's just first index times second index to get the index in the lookup table. But it doesn't really work that way. because you have to account for collisions. No, collisions occur when two values go to the same index, and this is a problem because one index can't hold multiple values in a lookup table. Was 3 was the index for the first letter and 4 was the index for the second letter. You multiply that, you get 12. But if it was 4 times 3, then that's also 12, because order doesn't matter when you're just multiplying two numbers. So then, if that's the case, then AL, which is would be at the same get the same index as LA, which is Louisiana. And this is a hash table. Two values can't be placed in the same place, hence there could only be one. To count the order in an abbreviation, we must make the function not communicative by multiplying the first index by 26, then adding the second index. You have to be aware of collisions and account them in situations where you need to account for multiple indexes in a code combination for the index to find the index on a lookup table. Finally, let's look at the uses. You could use it for data compression, encryption, translating symbolic notation, tabulating functions to speed up time-critical computations, fetching the red, green, or blue component from numeric RGB values from 0 to 255. Really exciting stuff right there. Let me just explain the data compression part. So let's say you want to decrease the storage and there's a word appearing multiple times in a text. Let's say you wrote Tim a bunch of times. You could just not allocate, but you could make a symbol, let's say an exclamation mark, equal to Tim. So then you could just replace it with Tim, not Tim. You replace Tim with that exclamation mark, and you don't have to write Tim so much, because Tim takes up more space than an exclamation mark. And you could do this with a bunch of stuff that appears multiple times, and you could put small symbols for it and find it easily using a lookup table. And yeah, this lookup tables are pretty simple and straightforward. I might make a video of going over specific problems or all that, but for now, this is good enough. I know it's short, I'm lazy, it's 3 a.m. But I'll be making a hash table videos soon, you already know.